Why didn't I not write anything down? Because I know what I'm doing. Because I know what I'm doing. Does this pen actually work, or where did I put it again? Over there. Oh, that one seems all right. I know. Here we go again. You're going to have a shut up. I know. Well, let's do it then. You know, hey. She won't shut up today. She really wants to see. I know. It's very nice. You're very cute, and everybody wants to see you in the videos. You will be a star of the YouTube. But I know it's not called the YouTube. I was making a joke. You're a cat. You don't understand English. Get out of here. So we're going to do some infinite limits. And she won't shut up, so we had to put her in the front of the video. Yeah, I know exactly. So I'm going to just do 3 canonical examples that I always do to show what we mean by infinite limits. Basically, what we're going to do is we're going to try and approach a finite value, and our function is going to blow up positive or blow up negative. So the first one I'm going to look at is our friend 1 over x. So graphically, its geometric avatar is this. I know. You don't know what a geometric avatar is. Neither do the students. Okay, but it's a fancy word of saying the graph. So what it's telling me is it's blowing up arbitrarily large negative as I try to approach 0 from below. And it's already telling me I have blow up arbitrarily large positive when I try to approach 0 from above. But those are approaching different values, so the limit is probably not going to exist. I already suspect from the geometric avatar that the limit isn't going to exist. What we're trying to say with the limit equals something, if it does exist, is saying that it behaved the same as I approached, even with a regular function. If I have that, what it's saying is as I approach from above, did it approach that single value, and when I approach from below, did it approach that? Did it go to the same value? Now when we're talking about infinity, we have to say, did it blow up the same, or did it blow up the same down, or did it blow up opposite? So in this case, in the picture, what it's going to say is we're going to say that this limit doesn't exist near 0 because the behavior on either side of 0 was different. It's an infinite discontinuity. I know exactly. You don't know infinite discontinuities are a couple videos from here. I'm going to look at the left-hand limit and the right-hand limit near 0. The limit as x approaches 0 from below of 1 over x is equal to, now, this is also hard too. You just want equals a calculation. But what I'm really saying is I'm looking at approaching 0, but from below. So x is near 0, but less than 0. So what that tells me is 1 is a positive number, and then we have over, as I approach 0 from below, x is negative, so I have a negative number that I'm actually approaching. So I'm blowing up arbitrarily. All I need to know is what the sign of this is. And this says that I have a positive number 1 over a negative number x, which says that we are tending towards negative infinity near 0 but below 0. When I try to do this from above now, when I try to approach from above, we'll get a different inequality. So the limit as x approaches 0 from above of 1 over x equals, what am I going to say there? I know the jig is up. There's no simplification I can make. There's no algebra that I could do to cancel everything to get rid of the discontinuity on the 0 or on the denominator. We're going to blow up. I want to know whether it blows up positive or blows up negative. And in this case, we're near 0, but above 0. So that says x is larger than 0 in an inequality, which says that we're going to approach a positive over a positive, which is going to go to positive infinity near 0, but below 0. We're describing the behavior of 1 over x near 0 from above and 1 over x near 0 from below. That was the avatar that we just erased. This is what we just described. And because those behaviors were different, the left-hand limit is equal to negative infinity, which does not equal positive infinity, which is equal to the right-hand limit. Therefore, we say the limit as x approaches 0 of 1 over x does not exist. That is hiding some information in there. What that's saying is we calculated the left-hand limit and the right-hand limit, and they blow up, but they blow up to opposite infinities, which were different, so we say they do not exist, but it's still describing this behavior of that function. Now we're going to step up to degree 1, so we're going to do the reciprocal of x squared instead of x. Now again, when I look at this function, let's look at its geometric avatar first. If we cheat, these are the Atari functions. Change your colors. Atari, shout out, give me some money. So you just shift these slightly and change their colors, and all of a sudden you got a t-shirt and I don't know, a copyright infringement possibly. So let's see. Let's just use one color and then we don't have to worry anymore. So this is the graph of 1 over x squared. Now we can see that, if you could see my view, you would see that the cat is cleaning herself right in front of everyone else as we try to shoot videos right in the middle of the floor. So this is a much better view now all of a sudden. So what this is telling us is our function now behaves the same on both sides of 0. It's going to blow up arbitrarily positive. So we're going to say the limit equals, we're going to cheat and say it equals positive infinity because they both went up. Let's calculate first. The limit as x approaches 0 from below of 1 over x squared is equal to a positive over a positive, because regardless, even though I check and x is less than 0, x squared is still larger than 0. So this is still a positive quantity, so we're going to approach positive infinity as we approach 0 from below, which is exactly what this is saying. Now I approach from above of 1 over x squared, and that won't change because if x is positive, x squared is still positive. So this is going to equal a positive over a positive, which is going to approach positive infinity. So this time the left hand limit equals positive infinity, which equals the right hand limit. Therefore the limit as x approaches 0 of 1 over x squared is equal to positive infinity, we say. What that's saying is it's describing the behavior near 0 on both sides of 0. It goes up. That's what happens to your brain as you try to calculate these. The last one we're going to do one more basically, and all I'm going to do is tweak the reciprocal again just to show you the other case that we could have where the function equals negative infinity. So what am I going to use this time? F of x equals the reciprocal of x squared now, but now I add a negative, which means that we've reflected it about what, everybody? The x-axis. It's on the outside of the function. So its reflection, y goes from its positive to its negative. So the original function that we were just doing got reflected about the x-axis. So this is our function now, negative 1 over x squared. What are we going to do with that? We're going to check the left-hand limit and the right-hand limit both equal the same thing, which will be negative infinity this time. The limit as x approaches 0 from below of negative 1 over x squared. X is less than 0, but x squared is still positive. Remember, why is that? I'm going to multiply both sides by x, but x is less than 0, so it'll flip the inequality. That's what's happening there, magic. So, but either way, it won't help us. This will be equal to now a negative over a positive, which is going to approach negative infinity. This is what it's describing. If you're not picturing the graph of a function near a value, you're doing limits wrong, because that's what they're trying to describe for us. Now, the limit as x approaches 0 from above of negative 1 over x squared. Now x is larger than 0, so x squared is definitely larger than 0. I check all the pieces. Now what that's going to say is that's going to equal a negative over a positive, which is going to approach negative infinity. So again, the left-hand limit equals the right-hand limit, which equals negative infinity this time. Therefore, the limit as x approaches 0 of negative 1 over x squared is equal to negative infinity, they say. What that says is on both sides, it blows up arbitrarily negative. It's me at my discretion. That's a dangerous thing.